Hi there, my name is Bernie Andringa. I'm an instructor of diesel technology at Skagit Valley College in Mount Vernon, Washington. I would like to take this opportunity to show you a project that I've recently completed. I call it my Caterpillar Engine Simulator Board. It contains all of the electrical components necessary for a late model Caterpillar truck diesel engine to operate, including the sensors, the actuators, the gauges, the switches, everything. It's all there. Two unique features about this board are that the wiring is all on the front face of the board, which really eliminates any mysteriousness for the students and anybody who's working on it. Everything is out front, nothing is hidden. Number two, it actually runs. With the help of some simulator wheels on the front, this thing will actually run. I can fool the ECM into thinking that it's actually running. I built this board for two primary reasons. Number one, it's a great recruitment tool. I take it to various high schools and other shows, and it draws a lot of interest. Number two, I use it as a training aid in my own lab with my own students. I'll sit this thing down on a table like it sits right now with a student in front of it, and I'll have them chase down a fault code or some other error, or maybe I might have them do some programming or recalibrating a speedometer. I found that this device is a nice bridge between the classroom theory and actually having them work on a real truck. Because as I said earlier, all of the components are right there, and this is everything on a 2-foot by 4-foot board. What we're going to do is we're going to take this camera, we're going to kind of zoom in on the components, and then we're going to take it for a spin, and I hope that you find this very interesting. At this time I'm going to zoom in and show you some of the components in some more detail. Starting with the engine ECM, that's this black box here in the center. You'll notice that there's two connectors on it. This connector serves all of the engine sensors and actuators. This connector serves the vehicle switches, gauges, components, and warning lights. As we move over here, you will see the engine sensors, including 3 pressure sensors and 3 temperature sensors. The unique thing about the pressure sensors that I have here is that I have put on the back side of the board some potentiometers so that I can dial in whatever pressure I want on the fly. All I have to do is swap these wiring harnesses over, and I can, again, using these potentiometers, I can dial in whatever pressure I want, whether it be barometric, boost, or oil pressure. Moving up, you can see that I've got coolant, fuel, and intake manifold temperature sensors, and they are sensing ambient air temperature, and those do not change. I also have a crankshaft and camshaft position sensors, and the crankshaft position sensor is actually attached to a motor on the back side of the board, and this is how I simulate the engine running. Even though there is a cam sensor, there is no cam wheel. It was too difficult to make that work, and it works just fine the way it is. On the top of the board are 6 injectors, and as you can see, there's only one real injector. For weight savings, I only put the solenoids on the other 5 over here. This injector actually clicks. It's actually quite loud and annoying, but it does work. Between each pair of injectors are the Jake brake solenoids. This is number 3, 2, and number 1 Jake brake solenoid. Looking at the vehicle side of this board, you can see that we've got a tachometer and a speedometer. These components actually are recessed behind the board, and the wiring for these components come out at these 2 points right here. This is the vehicle speed sensor. On the back side of this wheel is a little motor where I can actually dial in some speed. I'll show you that later. Right here is a coolant level sensor, and it's actually plugged into a little brass fitting which simulates my radiator. Inside this brass fitting is some water. I can actually drain the water out if I want to at this point right here. So I've got a working coolant level sensor. Here I've got some various cab switches, including clutch, brake, Jake brake on-off, Jake brake intensity, cruise control switches, fan override switch. I've got your various warning lights that you might find in the cab. I also have next to the warning lights a key switch and a little starter motor right here at this point. You can see that my little windshield washer pump here is actually my starter motor. Working below that, I've got a fuse box. And below that is the ground bus for all of the attachments that need, or all the components that needed to be ground. And at this point right here, I've got a diagnostic connector for plugging in laptop or ProLink for diagnostics. And then finally below that, I have a J1939 data link, and it is for communicating with things like auto shift transmissions and ABS brake systems. Moving up a little bit from that, I also have, this is my accelerator pedal sensor. It's hooked up to a knob. I've got an H and an L on there. H is high for full throttle, and L is low for idle speed. Okay, at this time we're going to take it for a spin. You can see over here that I've got the laptop hooked up. I've got the laptop connected to a communication adapter. So we've got communication going on between the laptop and the engine so I can observe what's going on. What we're going to do is we're going to take it for a spin. I've got two knobs right here at this point. One controls the engine speed knob, or the engine speed sensor, and the other controls the transmission speed sensor. And with the flick of the wrist here, I've got engine speed, and with the other knob I've got vehicle speed. And what we're going to do is we're going to take it down the road. We're going to set the cruise control, and I'm going to try to go about 60 miles an hour. And once I'm going about 60 miles an hour, I'm going to hit the cruise control on switch and then the set switch, and you will hear it ticking. That's the injector injecting fuel. I'm also going to hit the jake brake switch, after which you will hear the jake brakes come on when I overspeed it. You can see at this point right here, the center jake has come on. If I overspeed it a little bit more, two more jakes come on, and if I overspeed it a lot, all three jake brakes are on to slow the vehicle down when it's in cruise control. This is one of my favorite things to do. We're going to take it on a full load dyno run. What I've done right now is I've actually overspeeded the engine. You can see that it's well over 2,000 RPM. Red line on this engine is about 2,100. I've got full throttle, and the way I put a load on this engine is to slow the engine speed down. And so I'm going to slow the engine speed down by use of the speed control at this point right here. And with full throttle and full boost, what we're going to see on the laptop screen here in a moment is the engine going into full fuel. You'll be able to see the speed drop, the fuel increase, the torque increase, and we'll analyze the results after we're done. But what I want you to do right now is go over to the laptop screen and take a close look at this graph, and also listen to the injector make noise as it starts to go into fuel and lug down. Okay, that was the end of our dyno test. If you take a close look at the screen here, you can see engine RPM in red. This is the point where I started to lug it down. And you can also see when the engine came into fuel, you could see the percent torque in the engine load climbing. And at this point right here, blue represents percent torque. Maximum torque was between approximately 1600 RPM and 1000 RPM, at which point torque started to drop. And you will also notice that it follows very closely the factory torque curve that is provided by Caterpillar for this engine. Well, sadly we're out of time. I hope you found this interesting. If you got any questions or comments, feel free to contact me with the information given. I'd love to chat to you more about it. Otherwise, have a good day, and we'll talk to you later.